Okay, this is McGraw-Hill Chapter 5, Section 1, dealing with the simplification of rational expressions. In this section, it talks about the domain of a rational expression. And two questions you got to ask yourself when you're looking for the domain of a rational expression. First thing is the denominator cannot be 0. So you have to factor the denominator. Then set those factors equal to 0, and that tells you what x cannot be. Second thing is square roots. You cannot have a negative inside a square root. A negative inside a square root will make it imaginary, which will make it irrational as well. So letter A, we have x plus 4 over 2x squared plus minus 11x plus 5. Well, the first thing we have to do is we have to factor the denominator. The denominator is a trinomial. It can't be simplified by greatest common factor, so we factor it. We get 2x minus 1 times x minus 5. And we set our factors equal to 0. We get x equals 1/2 and x equals 5. So the domain of this particular rational expression is all real numbers except for 1/2 and 5. The way we write that in integral form, come from negative infinity, parentheses, to 1/2, parentheses, union, parentheses 1/2 to 5. That means we're not using 1/2, parentheses 5, union, parentheses 5 to positive infinity. This means we're not using 5. So it's all real numbers except for 1/2 and 5. In part B of this problem, you have x over x squared plus 4. Well, by inspection, if I plug a 0 in here, I still get 4. This is a sum of squares, which there is no factoring for. It's non-factorable. So this is all real numbers. There is no x that can't be used in this particular rational expression. So it's negative infinity to positive infinity. On this one right here, factoring is the most important part of this chapter. We have to simplify this rational expression. 2x cubed plus 12x squared plus 16x over 6x plus 24. So we have to factor top and bottom. Factor in the top, we bring out a 2x by greatest common factor. It's a trinomial that factors into x plus 4, x plus 2. The bottom, greatest common factor, bring out a 6. So now we factor top and bottom. We can see that the 2 is going to reduce the 6 to a 3 on the bottom. Still going to have x on top. The x plus 4 and the x plus 4 become 1. So it becomes x times x plus 2 over 3. Here's example 4, page 426. Here we're going to use nothing but the quotient rule. Simplify the fraction and use the quotient rule. 2 over 8 becomes 1 over 4, but we don't have to write the 1 on top. Remember the quotient rule. Take the smallest amount of x's away. So if we take 2 away from here, it gives us x is 0, which is 1. Take 2 from here, it leaves us x squared on the bottom. Take 3 y's from here and 3 y's from here, we get y to the 5th on top. So we have y 5 over 4x squared. Going to example 5, page 427, same thing. We've got to factor the top and the bottom. The top is a sum of cubes, which factors into t plus 2 times t squared plus 2t plus 4. Bottom is a trinomial, which factors into t plus 2, t plus 2. These t plus 2's become 1, so the answer becomes t squared plus 2t plus 4 over t plus 2. The hardest part of these problems is the factoring. You've got to be able to factor. In example 6, we have x minus 5 over 25 minus x squared. Well, what we're going to do is multiply this 25 minus x squared by a negative, which switches it to x squared minus 25. See, if I distribute this, I still get a negative x squared, and I still have a positive 25. So this is just another way to write this. This is a difference of squares, which factors into x minus 5 times x plus 5. The x minus 5's become 1, so this becomes negative 1 over x plus 5. X plus 5 is in the denominator's place, so it has to stay in the denominator's place.